More precisely, if dy by dx is equal to f of x, then we write y is equal to integral of f of x dx plus constant of integration, that is c. Let us now learn some terms and phrases and their meanings associated with the integration. In a question, if the term integrate appears, then it means we have to find the value of the integral. The process of finding the integral is known as integration. If we say constant of integration, then it means an arbitrary constant c. Now, let's look at some important formulae related to derivatives and antiderivatives. Let us now discuss the geometrical interpretation of the indefinite integral. Consider a function f of x is equal to 3x square. The derivative of x cube is 3x square. So, an antiderivative of 3x square is x cube plus c, where c is the constant of integration. For different values of c, we get different antiderivatives or integrals of the given function. Let y be equal to x cube plus c, where c is an arbitrary constant, represent a family of integrals. Let's now see how the curve of y is equal to x cube plus c looks for different values of c. For c is equal to 0, we get y is equal to x cube. The curve is as shown and passes through the origin. For c is equal to 1, we have y is equal to x cube plus 1. The curve is obtained by moving the graph of y is equal to x cube 1 unit along the y-axis in the positive direction. For c is equal to 2, we have y is equal to x cube plus 2. The graph is as shown here. For c is equal to minus 1, we obtain y is equal to x cube minus 1. The curve can be obtained by moving the graph of y is equal to x cube 1 unit along the y-axis in the negative direction. In a similar way, for c is equal to minus 2, we have y is equal to x cube minus 2, and the graph is as shown here. Hence, by assigning different values of c, we get different members of the family. These members of the family together constitute the indefinite integral. Now, let's consider the intersection of all the curves by a line x is equal to 1. The line x is equal to 1 intersects all these curves at different points. The derivative at the points of intersection of the curves with the line x is equal to 1 are equal to each other. This implies that the slopes of the tangents at the points of intersection of the curve and the lines are equal. This indicates that the tangents to the curves at these points are parallel to each other. In a similar way, if the line intersects the curves at x is equal to minus 1, then, in this case also, we can see that the derivatives at the points are equal to each other. Also, the tangents drawn at these points are parallel to each other. Thus, integral of 3x square dx is equal to x cube plus c. Let us denote this by f subscript c of x at the points of intersection of the curves by the line x is equal to a, where a belongs to R. This implies that the tangents to all the curves y is equal to f subscript c of x, where c belongs to the set of real numbers, at the points of intersection of the curves by the line x is equal to plus or minus a, where a belongs to R, are parallel. Further, let integral of f of x dx is equal to g of x plus c is equal to y represents a family of curves. Different values of c give different members of the family, and these members can be found by shifting any one of the curves parallel to itself. This is the geometrical interpretation of the indefinite integral.